Good day, pre-calculus. This is Mr. Langston again, and I am doing the second of my videos that I needed to do to get caught up for today. This video is on the lesson that we had, in fact, yesterday, which is Friday, August 25th. And first thing we have to do is, of course, the warm-up. Now, remember what I told you? The notes actually from yesterday did not cover this warm-up, and I did this with you. So when you're asked to find the domain, you are asked to basically find all the x values that are allowed in the function. And of course, the x values that aren't allowed in the function are x values that are going to break a mathematical rule. So in this case, we have a fraction, and we know that we cannot have a 0 in the bottom of the fraction. We can have whatever number in the top. We can have 0, we can have 1, we can have any number in the top, but we just can't divide by 0. Once we divide by 0, it's total anarchy. Cats are sleeping with dogs. Money doesn't mean anything. It's just terrible. So we can't divide by 0. So what we've got to do is find all the x values. So find all x values where the bottom of the fraction, or shall I say, the denominator of the fraction is equal to 0. So I need to find all the x values where the bottom of the fraction, the denominator, is equal to 0. So I'm just going to take that denominator, 3x minus 4, and set it equal to 0. And I'm going to solve. And that'll give me the x values where the denominator is equal to 0. So solving it, add 4 to both sides. Add 4 to both sides. When I do that, I end up with 3x equals 4. And now divide everything by 3. X equals 4 over 3. And that's equal to 1 1/3. So at x is 1 1/3, I can't have it. I'm not allowed to have x being 1 1/3. It can be every other number aside from 1 1/3. I can, if I want to put and make a number line, I'm saying that here's 0, here's x is 0, here's x is, we'll say this is x is 1, and here's 2, here's 1 1/3. And x can't be that value, so I'm going to represent that as an open circle. X can be every value to the left. It can go on to negative infinity. And x can be every value to the right. It can go on to positive infinity, but it cannot be 1 1/3. So the way I represent that, I can say x cannot be 1 1/3. Okay? Or I can represent it better yet in interval notation. I can say the domain, and I don't know why I have that slash there. The domain is x exists between, and now I put it. I can go from negative infinity to 1 1/3. So negative infinity to 1 1/3. And then I can go from to the right of 1 1/3 all the way to positive infinity. So I'm going to say 1 1/3 all the way to positive infinity. And there you go. That's your domain. And that answers the question here. And I've cleansed the demon. Praise the Lord. So this is the graph right here of what our warm-up is. So I plugged it in Desmos graphing calculator and I graphed it. I cut that out for you. And you'll notice that 1 1/3 is roughly about here. So, and that's a lousy straight line. Okay, that was an awful line. Notice that it gets close, 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 close to 1 1/3, but it doesn't touch. This line, whenever we are excluding values from the domain and I end up with a fraction, that 1 1/3, that line is called an asymptote. 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 Okay? And it's a line that the graph, notice that the graph gets crazy close to it and it's going to snuggle up to it, but it's never going to touch it. It's just going to get close, 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 but it will never ever touch it. Okay? And notice that it takes on every single x value. It can go on to negative infinity here, and then it kind of stops at 1 1/3. It just gets close, but it won't cross it. And then it starts on 1 1/3 here, and it goes all the way down. And when I say here, I mean here and all the way down to positive infinity. Now, it's my understanding. I'm using my laptop right now. And when I use my laptop and I don't have it hooked up to a computer monitor, it's my understanding that you don't necessarily get to see my little pencil where I'm drawing. It just kind of magically appears to you. I'm sorry. It's a feature of me recording while using the laptop in laptop mode. I kind of don't have control over it. This is going to happen when I'm recording at home because I don't have a monitor to hook up to it. So I'm sorry. So sorry. But that's the way it's going to be. So I'm going to try to start drawing whenever I'm saying, oh yeah, you go here and then over here and then here. So I'm going to try my best to draw so that way you can see exactly what I'm talking about. It'll mean that I'm erasing a little bit more, but I'm going to do my best. So today we're doing section 1-6, and it's called a library of parent functions. Okay. And our focus standard is functions and their graphs. Our content objective is recognizing simple parent functions. And parent functions are functions that basically things stem from. They're the functions that are just like your basic version of a function. Power standard, you guys are going to model by graphing. And our language objective, you're going to be able to communicate with each other and articulate what a unit step function, or as the textbook says, the greatest integer function is and how to graph it. So first off, we're going to start off really just by graphing. And you guys really need to use the table of values, even though you're just like, hey, man, I'm in pre-calculus, man. I'm a senior, I'm a junior. I don't need to put a table of values. Well, actually, your test scores kind of say you do. Okay, you really still need to be graphing. You're not at that stage yet where you can just start graphing in your head. So I'm going to tell you guys, I'm going to warn you, I'm going to say it all the time, plug in your table of values, please. So first thing I'm going to start off is I'm going to graph f of x equals negative x squared. So I'm going to plug in a 0. I'm going to put that in the middle. X equals 0. So what I'm really evaluating is f of 0 equals negative 0 squared. Okay, so 0 squared, 0, negative 0, 0. Boom, I got my first point, 0, 0. And then I'm going to plug in 1. F of 1 equals negative 1 squared. So that gives me negative 1. 1 gives me negative 1. Boom, right there. And next I've got f of negative 1. I'm going to plug in negative 1 equals negative 1. Whoa, I don't even know why my computer did that. It just happened. So negative 1 squared. So negative 1 squared, that's equal to 1. And then bring this negative over. Boom, negative 1. So I can pretty much already tell what the graph's going to look like at this stage of the game. I'm going to clear these out so I can get some room to still do some more graphing. So I'm going to plug in 2. So I've got f of 2 equals negative 2 squared. Well, that's going to be negative 4. And on this side, I'm going to tell you if I plug in negative 2, I'm also going to get negative 4. So 2 gives me negative 4, boom. And negative 2 gives me a y value of negative 4. So what I can tell is I've got a parabola. And it's a parabola that opens down. And that was a lousy tracing of that line. Man. Okay, let's try it again. Whoop. Right there. That's better. Okay, so it opens down. That's a parabola. That's what you're going to do. So if I graph this one again, make your table of values. So I've got X, I've got Y. I'm going to do that, make my T-chart. I'm going to start at 0 just because I like to start at 0. It's just means. So when I plug in 0, f of 0 equals negative 0 cubed. And that ends up being, yep, negative 0, which is 0. So boom, 0, 0. F of 1. So let's plug in 1. Negative 1 cubed, negative 1. F of negative 1. That's negative 1 cubed, which is negative 1, which is positive 1. So I've got 1, negative 1, 1, or negative 1, positive 1. Okay, let me plug up here. I just want to utilize space. F of, in this case, we'll do 2. And that's going to be negative 2 cubed, which is negative 8. So that's like down, I don't know, about like around here. And f of, in this case, negative 2. Let me just do negative 2. That's going to give me negative 2 to the third, which is negative 8, which is a positive 8. And that's going to be about right here. So when I do my graph, I'm going to come down and like that, and it's going to switch and move up and like that. This is going to look like that. Put our little arrows because I just like to. So here's the thing. I remember in the last section, I talked about even and odd functions. An even function, and I'm just going to show you graphically now. An even function has a line of symmetry across the y-axis. So that way, if I take and I fold this over, if I fold it on this line like a paper airplane, this side here will overlap this side here. That's an even function. This, I can tell you, is an even function. This is an odd function. Odd functions are flips, double flips. So if I take this down here and I flipped it up, it would look like kind of like this up here. And then if I flipped it up, and then if I flipped it over now, this part would overlap this part. So it's a flip. This function here, f of x equals negative x cubed, is an odd function. Odd function. So let's do this one. This was a piecewise step function. So we got f of x is equal to 2x plus 3 when x is less than or equal to 1. And it's negative x plus 4 when x is greater than 1. You're going to use your t-chart. I'm going to say X and Y. So I'm going to start at 0 because I just like to start at 0. So when I start at 0, I'm asking, am I going to use the top or am I going to use the bottom? This part is the key. This tells you. So if X is 0, 0 is less than or equal to 1. So I'm going to use the top. So I'm going to plug it into the top. So 2 times 0 plus 3, that gives me 3. So at 0, I'm at 3. Let's try 1. At 1, I'm going to plug it into, and in this case, still the top function, because right here, 1 is less than or equal to 1. So I'm going to plug it into the top. So 2 times 1, I don't know why I put an equal, plus 3 equals, in this case, 5. So at 1, I've got 5. Let's do negative 1. I'm going to plug it into the top. 2 times negative 1 plus 3 equals 1. So I'm right down here. So I can see the pattern. I'm going down to left 1, down to left 1. I can already see that pattern. So that's what the top function looks like. Now I need to do the bottom. Well, that's when I get greater than 1. So the next integer I have is 2. Okay. So at 2, I'm going to plug it into the bottom. So now I have negative 2 plus 4. And that's equal to, in this case, negative 2 plus 4, 2. So at 2, I'm at 2. And at 3, oh, and I didn't plug these in. Sorry. I should have plugged those in right there. I should have filled it in. Kind of got a little carried away. At 3, I'm at negative 3 plus 4. So that's 1. And at 4, I'm at negative 4 plus 4, which is 0. So I think you can see the pattern going on. Now, I've got my line going here. Whoa, that messed that up. Seriously, I did a lousy job with that line. Let's back that train up. I got my line going right here. Now remember, X is greater than 1, so I can be crazy close to 1. In the bottom function, I can say I'm at 1.0000000001. Well, I can even be closer than that. I can add another 0, 1, or closer than that. And I can keep going, getting closer and closer to 1. So this can creep on close and close and close to 1. It just can't touch 1. So another way that I'm going to show getting closer to 1 is, because I want a graph kind of really close to 1, basically almost on top of 1, so close that you can't even tell with your eye that I'm close to 1. And the way I'm going to represent that is 1 plus, and the plus means just to the right of 1. So 1 plus means just to the right of 1. Just like 1 negative would mean just to the left of 1. It's not a power. I'm just making a symbol to represent. So if you're just to the right of 1, I mean, it's like so close to 1 that it may as well be 1. Okay? It's just so close. We can treat it like it's 1 because it's that close. So if I plugged in 1 plus, I would have, in this case, negative, and I'm plugging it into here. So I have negative, and I'm plugging, what's here? You guys can't see my pencil. I'm plugging into the bottom. So I have negative 1 plus 4, which is basically equivalent to negative 1 plus 4, which is 3. So right here, close to 1, it's the value of 3. Now I can't get at 1. So I'm going to just represent this 3 with an open circle, this point 1, 3 with an open circle, and now I'm going to connect the rest. So that's how you graph a piecewise function. That's what it looks like. Yay! So there it is. Now, what we've got here is familiarity basic functions. So they want you to know these functions. So I've got a constant function when my slope is exactly 0. Okay, notice all my y values are the same. I've got all my y values the same. I have, and they call this the identity function. I've actually never heard of this as the identity function, but there you are. It's a linear function where, oh, I see why it's called identity. Okay, it's a linear function where the slope is 1. And the reason it's identity is because if I go to x is 1, my y value is 1. If I go to x is 2, my y value is 2. If I go to x is -1, my y value is -1. And if I go to x is -2, my y value is -2. So they call it identity function. I've got here an absolute value function. It looks just like a v. I have a square root function. It looks like a parabola that's been turned 90 degrees, rotated 90 degrees to the right. I got a quadratic function, which is just your basic y equals x squared. I have a cubic function right here. And I've got a reciprocal function. And the reason it's called a reciprocal function is because, look, it's like taking the reciprocal of x. And I've got here, which is called the greatest integer function. Now we're going to take a look at the greatest integer function closer, because the notes really don't cover it very well. So we have the greatest integer function. The way I learned it when I was younger, I learned it as the unit step function. Now it's represented by the equation f of x equals, and they put like 2 brackets. So I've got a bracket here. Let me show you. I've got a bracket here and another bracket here on top of it. Okay, bracket, bracket. The way I learned it was f of x equals a bracket, but the bracket only ends in the bottom. Okay, now the reason they have this is it kind of tells you to basically squish down your x. So that way, or shall I say squish down your y to the next lowest integer. So for instance, if I have my x here, and normally, let's take an identity function. It's kind of like squishing down an identity function. What happens is if I'm any bit above the integer, for instance, if I'm going any bit in the y direction above the integer, this gets squished down. So it's kind of like chopping this down and squishing it so it becomes a stair. So at, let's say, here, it's squished down to the bottom. So it's squished down. It's making a step. Okay, it makes kind of like a stairway. So it's kind of like you saw something on top of the stairs, whatever it was, a bug, and you just mashed it into the carpet. And that's what you're doing. You're mashing things down and you're making a step. You're mashing it down and making a step. Another way to think of it is you're taking the x value, whatever the x value is, and your y value is rounding down your x value. Your y value is rounding down your x value. So for instance, if I have f of 1.1, my x value is 1.1, I'm going to round that down to 1. F of 3.2, my y value is going to round down to 3. So I'm just rounding everything down. Now here's f of 0.7. I'm going to round it down to 0. Here's where it might get confusing. What if I have f of -0.7? 0.7. I'm not going to round that down to 0, okay, because technically I'd be rounding it up. If I'm at negative 0.7, okay, on a number line, if I'm on negative 0.7, so here's 0, here's negative 1, here's positive 1. If I'm at 0.7, I'm like right around here. Let me put it in a different color. I'm like right around here. So if I round it to 0, technically I'm rounding up. To round it down, I've got to take that to negative 1. So I round negative 0.7 to negative 1. Same thing is if I have f of negative 1.3. Negative 1.3 is, let me just fix this. So here's negative 1. Here's negative 2. Negative 1.3 would be right about here. I'm not going to round it to negative 1. I'm going to round it down to negative 2. So notice, negative 1.3, that's like, that's a little far. Negative 1.3 is like right over here. Notice it gets rounded down to negative 2. You guys see that? It gets rounded down to negative 2. So the only time I have open circles are when I'm at the integer. So for instance, if x is 1, I'm staying all the way at 0 until I get to x is 1, and then I can jump up to 1. And then I stay at 1 until x becomes 2, in which case it's an open circle, and I jump up to 2. And it stays this way until x is 3, and I jump up to 3, and I keep going like that. Okay? So that's really all I've got for the notes. It was crazy short this time, not very long, just crazy short. That being the case, you got your homework. No, you don't have your homework. I'm going to post your homework because I didn't get a chance to post it on Friday. So I'm going to post it today right after this video. So take care, pre-calculus. Have a great and safe weekend. Do your homework and peace. Bye.